In this video, I'm going to talk to you about probability. It's 2022 paper 2 question 1. The first part of this question is quite straightforward. It simply gives you a table and it discusses whether students in a university are less than or equal to 23 years old or greater than or equal to 24 years old, and which of those are undergrads or postgrads. So they've told me that there's, of the less than or equal to 23, there's 12,785 undergrads and there's this many postgrads. So you simply add them together and it tells you that the total number of people less than or equal to 23 years old is 14,138. For the 24 and over, we know the total and we know the number of undergrads. So if I subtract 2922 from 8576, you get 5654. And then there's a couple of ways of getting this value. You can add up the number of postgrads for less than or equal to 23 and greater than or equal to 24, and it tells you there's 7,007 of them. In part B, we're told O is the event that someone in this university is 24 years or older. So I got the probability of O, it's 8,576 over 22714. In other words, all the students over 24 or over divided by the total number of students. That's the probability someone lands in the set O. U is the event that you're an undergrad. So we get the total number of undergrads, which is 15,707, over the total number of students, which is 22,714. We're asked to investigate if these are independent events or not. Remember your definition for independent events. The definition that you've learned for independent events is basically the probability of O multiplied by the probability of U. If they're independent, then the probability of O multiplied by the probability of U should be the same as the probability of O intersection U. So that's the formula that I need to sub into. I've already worked out the probability of O, I've worked out the probability of U, so the other thing we need to work out for this is the probability of O intersection U. In other words, the proportion of students that are 24 years or older and are undergrads. They need to be both of them, and that is 2,922. So you take this and you divide it by the total number of students. So now I have my three probabilities. I'm just going to sub them into my formula and see does it work. So I've subbed in my values, and when I plug the left hand side into my calculator, I get 0.26109. When I plug the right hand side into my calculator, I get 0.12864. Obviously they're different numbers, so the events are not independent. Now, it should have been clear to you from the start that they weren't going to be independent anyway. You can clearly see from the table in part A that younger students are more inclined to be undergrads, while older students are more inclined to be postgrads. So the event that someone is over 24 or over, and the event that someone is an undergrad, they obviously aren't completely independent. Age and whether you're undergrad or postgrad, there is a relationship between the two, but to get the marks you need to do it mathematically to show you know your stuff. In part B, we're told that 3 people are chosen at random from a class. What's the probability they're all born on the same day of the week? So you might make a silly mistake here, but if you figure it out, it's easy enough. I'm going to select a person at random, and maybe they're born on a Tuesday, or like the very first person was definitely born, and I don't care what day of the week they were born on. So the probability is 7 out of 7, or it's just 1. I'm just going to select someone and I want to check where they were born, and obviously they were born if they're a person. Then I want to select a second person. If the first person was born on, let's say, a Tuesday, I want to know what's the probability the next person I pick was also born on a Tuesday, and the chances that you're born on a Tuesday is 1/7. Then I want to select another person at random, and I want to check what's the chances that they were also born on Tuesday. It's 1/7 again. I want to select the first person and the second person and the third person, so you multiply the 3 probabilities by each other, and your answer is 1 out of 49. There's a 1 in 49 chance that you randomly select 3 people and they're all born on the same day of the week. Okay, in part C, we're told that there are B boys and G girls in a class. So there are 2 unknowns, which means we need to come up with 2 equations and do a simultaneous equation to find B and to find G. You'll clearly see that we are given 2 pieces of information, so with each one we should generate an equation. I'm told that there are B boys and G girls, and I'm told that initially the probability that you randomly select a girl is 3/5. 3/5 of them are girls. So if there's B boys and G girls, I first want to figure out what's the probability that you'd randomly select a girl in terms of B and G. Well, if there's G girls, I want to select G girls, and the total number of people in this class is B plus G. So G, the number of girls, over the total number of people, represents the probability of selecting a girl. And I'm told in the initial scenario, the probability that that occurs is 3/5. So there's one equation with two unknowns. That's the first half of my simultaneous equation. Now, to come up with my second equation, I'm told that we add in 4 more boys and 4 more girls. So that means the number of boys now is B plus 4, the number of girls now is G plus 4. And we're told that if you do that, the probability that you'd randomly select a girl is now 4/7. So let's follow the same logic. If I want to pick the girls, well, the number of girls is G plus 4, and I want to divide that by the total number of people in the class, which is B plus G plus 8. If you add them together, you get B plus G plus 8. So this is the number of girls, and this is the total number of people. And in this scenario, I know the probability that that occurs is 4/7. So now I have 2 equations and 2 unknowns. I'm going to be able to solve it. However, let's simplify it a little bit. I think that's the key. If you get that, the rest of the question is straightforward enough. What I would do here, to get rid of the fraction on the right, I'd multiply both sides by 5. To get rid of the fraction on the left, I'd multiply both sides by B plus G. Some students think of that as cross multiplying. So what I can write this as now is 5 times G is equal to 3 times B plus G. I'm going to go from there in a moment, and I'm going to simplify it further. I'll do something similar here. I'll multiply by 7, so I get 7 times G plus 4, and I'll also multiply by B plus G plus 8, so it'll be equal to 4 times B plus G plus 8. So all I'm doing there is getting rid of my fractions, and let's take these 2 equations. We'll work from here, and it's a simple enough simultaneous equation. So all I've done here is I've simplified further. I left you the first equation we came up with was 5G equals 3 times B plus G. I've just multiplied that out, and I brought everything to one side. So my first half of my simultaneous equation is 2G minus 3B equals 0. With the other one, I left you here. I just multiplied it out now. I've brought my letters to the left and numbers to the right. So my second equation is 3G minus 4B equals 4. And now let's just solve it. So the way I decided to do this was to get rid of my G's. It doesn't really matter which way you do it, but I multiply the top line by minus 3 and the bottom line by 2. And then I end up with 6G minus 6G, which cancels, 9B minus 8B, which is B, and 8 plus 0, which is 8. So I get my first answer that B is equal to 8. Then I decided to sub into the first equation. I subbed in B equals 8, and I end up with G is equal to 12. So that's your final answer for this part of the question.